Hello everyone, and welcome to this short video about using event mining for longitudinal data analysis. Event mining in a nutshell is about finding relationship between different events that may happen during a user's day-to-day life. And in this video, we'll try to find out if different types of exercises during the day impact the user's heart rate while they are sleeping. So the first step is to specify different data streams and event streams that we want to include for the analysis. These data streams and events can originate from different devices such as smartphones or wearable devices, or different applications such as Personical or Food Log. In this analysis, we have included the heart rate and steps data stream and various lifestyle, exercise, and sleep stage events that are available for this particular user. And we can also create new events from the user's data streams by using simple range-based transformations. In this instance, we have specified a resting heart rate zone transformation, which will create different resting heart rate zone events from the user's heart rate data stream. And once we press submit button, all these data and event streams would be loaded and will be available for analysis. In the visualization tab, we can plot all the selected events on a timeline. For our analysis, we would also want to aggregate all the sleep stage events in a single event stream. So I have already done that and created a new event stream called sleep stage, which includes all the light, deep, and REM sleep events. And we can do that very easily using the event operations that are part of the dashboard. So let's create a new event stream called sleep_stage, which includes all the deep sleep and REM sleep events. And these two event streams can be combined using the OR operator, since we want to include both the deep and the REM sleep events. And once we press the add button, it will create a new event stream called sleep_stage, which will have both of these event streams. We used the same operator to create the sleep stage and the exercise event streams, which include all the sleep events and different walking and cycling events respectively. For our analysis, we next need to find out what are the different resting heart rate events that happen while the person is sleeping. And we can do that by using pattern operators. We can create a pattern called sleeping heart rate, which looks at different sleep stage events and different resting heart rate events. And we want to find out the combination of these two events that happen concurrently. So we can do that using concurrent co-occurrence pattern operator. And once we press add button, this new pattern will be created that will show up in this list of patterns. As you can see, this is a newly created pattern which correlates sleep stage and resting heart rate events which happen concurrently. Now we can use this newly created pattern to find out all the heart rate events that happen while the person is sleeping from this event selection from pattern operation. So let's create a new event stream called sleeping heart rate events, which will utilize the sleeping_HR pattern and select all the resting heart rate events from this pattern. Now we can use these newly created events and correlate them with the exercise events that happen in the day before the sleep event. So we can do that using the temporal sequential operator. And to do this, we'll use the same pattern operator tab, and we can specify the two events as exercise events and sleeping heart rate events. And since the pattern operator is a sequential conditional operator, we would need to specify a time window within which we want to look for the co-occurrences of these two events. And once we do that, we can create a new pattern called exercise versus sleeping heart rate. And we can visualize the co-occurrences of different sleeping heart rate events with different types of exercise events. From this heat map, we can see that for walking, about 65% of the heart rate zone events belong in the resting heart rate zone 2. and about 2% of the heart rate zone events are of type resting heart rate zone 1. While for cycling, the same events have about 58% and less than 1% frequency. So, this may lead us to believe that walking leads to a lower sleeping heart rate than cycling on an average. Now, in our analysis, we have not included the effect of different confounding variables such as time at which the person woke up or their stress level during the day, but we can include those confounding factors using the same pattern operators. You can access a version of this dashboard at www.theeventminer.com. If you are interested in using this dashboard for your data analysis, you can upload your own data set and create different events and find out different interesting patterns